Am I just trying to go through normally or trying to optimize a lot? Sort of both. I mean, I'm not trying for the highest possible score. Well, I already finished the game, first of all. So now I'm kind of going back and going faster. But, it varies based on which puzzle it is. Some puzzles I like more than others. I have not had a nap, so we'll see how long this stream goes. I just wanted to get back, and I wanted to, if not get it completely working, I want to at least make progress over the bug last time. So what happened last time was we're navigating our binary tree, and then we end up infinite looping. Where's the... Yeah, so you see this is the furthest left item in the tree. I mean, it's hard to tell from the list, but it's the lowest item in the sequence, which is what you get by going left. So the first thing that we output should be the furthest left. So we're going to jump here, and then we're going to see. Okay, so we're here. So we seek -3. Boom. Copy F to M. That outputs these two. So the other guy's going to put those two in the file, the AR blah, and then -63. So now we go seek 2. This is the right side link. Copy that to T. We zero it out. We actually don't need to zero it out if it was already 0. So maybe we can do something about that later. It is not true, so we don't recurse. So we seek -2. This should have been where we came from, but it's not. And the reason I know that it's not is because see how it's the same number as this one in the right column? It's because those are the numbers that we wrote initially. So when we came down into this, we were supposed to write it. Oh, I can get an instruction back. I don't think this traverse label is used by anyone, is it? No, it must be actually. Because there's a jump right before it. Who says jump traverse? There we go. Okay. Well, so before we go to output, we're traversing copy T to X, do all this. How we can get rid of so many of these. Multiply T by 6, seek T. We copy F into T. Okay, so we only write this number in if our left link, wait. If our left link is false, we don't write that in. That's not good. Okay, we want to go. We need maybe these 2 more instructions before we start shrinking things. We want to go. Instead of seek 3, which puts us here, we want to seek 4, copy x to f, seek -2. I mean, we can probably condense this again, but let me just get it going. Okay, wait, so we copy t to x. Whoa, that was wrong. That was really wrong. Wait, we seek to the beginning of the file. We seek forward 3. We seek t, we copy f to t. So this is a read from the file at 3 plus t times 6. Yeah, so we're going to, let's do these in the opposite order. So we're going to seek, instead of 3, we're going to seek 4. We're going to do that. See what happens. Oh wait, -2, sorry. Because this increments the file pointer. All right, so we go. We seek 4, copy x to f. So here it's like, oh yeah, we came from 0, it's fine. Let's go to next time. We seek 4, copy x to f. What? Ah, this is the wrong number. We're just always, this is the number that we're seeking to. Damn it. We need to know where we're coming from, because that's how we return back. No wonder this didn't work. So when we go to recurse, okay. I don't think I actually needed to do this. Anytime we go to recurse, x needs to have who we came from. And we're not. Okay, we're back to this one. Okay, great. So x, we shouldn't be copying t to x here. Oh, that used to be correct, but then like I moved it up to the top of the loop because we had the same code or something. Okay, wait. We copy the message to M, we seek to. we copy the link to T. I think we just do it here. Okay, no, we gotta redo. Oh, I blew it away. Okay. So before I finagle this, I want to do something else to simplify. So all these multiplies here, no, let's not. I don't know. That's not. Let's keep it. I'm just going to run out of instructions. It's going to kill me if I don't do this other thing. Okay. What happens is we want to put we want to put 0 in x. For the initial loop, like right here. And then x is the carryover from the previous loop. But the thing is, we want the t that happens before we multiply. In principle, if we didn't need to multiply, which was why I was about to take this out, we could have done it there. But we're going to seek 4. So we're going to do that. That takes too long. We'll simplify it later. And now the problem is we need to copy t to x. Oh no, we have this one, which we shouldn't do there. So after we write in x, then we copy t to x, hopefully. Okay, first time, x is 0. Second time, x is still 0. That's correct, though, because we came from node 0. So we're putting that there. Well, okay, third time. We came from node 1. Oh, I don't like where this is going. Came from node 4. We're not seeking correctly. Okay. Now we're really screwing up. What's ending up in our output? Well, we don't know. What's ending up in our output? I don't think anything. Oh, no, we're still doing the same thing. Interesting. We're still doing the same thing. What is my major malfunction? I just need the node that I came from to be there, but it's not. 0, 1, 2, 3, 4. It's my node is there. Why? Why? Okay, wait. We don't have to put this there right now. We could put it in If we want to make an extra slot, which would cost us an instruction elsewhere, but might save some here, we can just have a slot for the parent node instead of overriding it, and we can write it in when we put this guy in. Let's do that. Since we're not using this one, okay. We're still in the same spot. Okay. Yeah, just to make things less crazy, before I try to do this, I'm going to make this t be, instead of an index, it's going to be an absolute offset of the node from the start of the file. What that means is, since our first two things, or our first one thing is just an index, so that's going to be 1. Here, we add this is weird. So we go to the beginning, we seek 1 forward. So here t is an index. This is just going to be seek t. This is going to be an absolute offset in the file. Okay. I'm going to mess this up, and we're going to be working even worse, but okay, when we add something in, wait, what? That's sad that we have to spend 1 there. So t is the offset of the node. Okay, so here we get t out of the beginning of the file. We add 6. Copy it back to the file. Who knows if that's all going to work? Well, not exactly. I guess so, though. These are the correct offsets. We just may not be seeking. Like these seeks probably have extra numbers in them and stuff. The 4s and the 2s and the 3s. Okay, so we seek minus 9999. We have x as the offset. That looks right. Okay, wait, the insertions all seem to work. Oh no, they don't. No, they don't. They have zeros in them. They have zeros. So wow. Wait, we want to traverse? The file pointer is there. It's in the wrong place. Why is T 0? Seek to the beginning, copy F to T, which should be 1. Go back, add that, copy T to F. Go back to the end. Oh God, this destroys our T. This is bad. Oh boy. So T is 0. That's still not good. What? T is now 7. Why was it? So we're writing the initial node. T is 0. All right. Those need to be 1s. Because those are the offsets of where we came from. Okay. Boom. We write the next node. Its offsets are correct. Okay. We're inserting at the right node. We seek 3. That is so bad. So this is so bad in so many reasons. Okay. So first of all, I totally broke this. So okay, this was a null pointer. Ugh. Okay. This is terrible. Did I top Fabian? Fabian hasn't done this level yet. What type of sort is this? Here, we're putting things in a binary tree, and then we're navigating the tree. And it used to be that putting things in the binary tree worked. And now I was trying to simplify the code, which of course in this game involves making it more complicated. And now I broke even that. So I'm trying to figure out why I broke it. You could do the equivalent of test t equals 1 without destroying t. You can. I don't know how. Except in 3 instructions, subtract 1, false jump, add 1. I mean, so, yeah. Yeah, I mean, if I want to pay the instruction. It's a good point. It's a good point. I think I can get away with having it where I am, but frankly, I'm just really confused right now. I don't know which way is up at this point. I think what I'm going to do like I was doing this thing where I kind of try to override the parent node, and it's not so great. So like for clarity, I maybe want to put the parent node in at the start and change this whole, while things are broken, why don't we just change the whole format, honestly? Where is the best place to put the parent node? It's like right after we've output. We want the parent node here after M. So here's the thing, we're not using this anymore, or we're not using this at all. That would reduce our thing to 5, so we would have to change these 6s to 5s, except that here, no. Meh. Where do I want it? Here. We're putting the parent node there. Now the question is when, okay, when we insert a node, it might be hard. Oh no, because we seek to the end of the file and seek -4 and write it in. So we go to the top. We copy the current node. We seek to, we seek T. We copy our X, which is our current node index, into the file. Instead, we'll do we need to do this both for the left node and the right node. I don't have enough instructions to do this. So we would seek 9999. I'm confused about what's happening here. Okay, in the first slot, we have the seek index of the last node in the file. And we are go to the end. We write these things down. We go back here, which is the same as going -6 from here, but we might get here from a different path. So oh, this is gonna, yeah, actually putting this here is gonna hose us because we need to be able to recurse back up to this node later. So we got to do it here. So painful. Okay. So we seek back, we seek T. If X is less than F, let's just say it is. We seek 1, seek 2 now, because we got to go to the right node link. Because we added a parent node right here. So we copy that slot, which is this one, to T. And if there is a node, we go to next node. If there's not a node, and we copy F to T. Why are we doing that? Oh, because that's our offset, this one. Then we go back, we get in X the I don't understand how this ever worked. Because we're getting out of there the current node also. Okay, wait. Seek to copy the left link. We know it's 0 here, so we copy our offset into T. We seek back. We copy our offset again. That doesn't, it's not good. And then this is always going to be true. Oh wait, no, sorry, I skipped. So we copy F to X. So now X and T probably have the same thing. So yeah, I deleted something here that we need. Yeah, we're supposed to copy T to F here. We're supposed to hold in the first slot. I must have thought that that was unnecessary before. No, what happens is we get the value out of the slot. This is probably 4. Dude, I don't know. I'm so confused about these things. Okay, so for right node, we do this. Yeah, 4 would be the right slot. And then oh, dude, this expects our thing to be there. Wait. 1, 2, 3, 4. Yeah, 4 would be this. We want to actually seek -2. Wait, what? Yeah, we have to seek -2 right here. We're at 150. Okay, right node, right node. How are we doing? Okay, that's correct. These are all correct. Okay, we're never still writing the parent index in. So that's unfortunate. And in fact, we died after writing the second entry. So we got something else wrong. Okay, we write the first node, we write the second node. We try to insert it. We put our offset in the first line of the file, which is 7. Good. We don't want to seek t. We want to seek t minus 1. Because we want to be at the head of this. We need an instruction that we don't have. Okay. I'm going to reverse my decision. About having this explicit node here. We're going to have 5 things. Just when we're getting it working, we're going to mess it all up again. We're going to have 5 things. These seeks are like all going to be 1 less. God help us. I don't even know where that is. This is super messed up. We're not even going to worry about that yet. Okay. Second 5. Step. Where are we? Okay. This is my offset from the beginning of the file. This is the left link. This is the right link. You have put my offset into the top. We don't actually want that. What am I doing? What am I doing? Why am I inserting this node to itself? Because I got confused. After we write a node, I had this here before and I changed it for some reason. We always want to start We always want to start with t equals 1. Because that's the root node. 1, 2, 3, 4, 5. Oh, these don't line up as nicely now that they're 5. 1, 2, 3, 4, 5. Okay, this guy thinks he's 6, which is bad. They all think they're 6. And that is because of my copy 1 into t. Dude, I have no idea what's happening there. So we seek to the beginning, we copy t to f. No, this should be. Okay, so we're going to the root node. We should be at the beginning of the root node, yes. Test x is less than f. It is. We seek 1, which gets us to the left link. I should just put the value at the end, man. Copy f to t, jump to next node. Nope. It's null. So we get that. Now t is our offset of this record, which is 1. That's correct. We jump to the beginning of the file. We get... That's not right. Okay, wait. Why do we have a 1 at the start of the file? I thought here, so here, we get our second record, right? Our first one's already in the file. We get our second record. We put 6 in the head of the file. Okay. 6 is in the head of the file. Now, okay. Now I'm being stupid. This is not right. So we go ahead, and this is not right. I hope. All right. I was getting confused about which number is where, which is obviously happening when all your values are anonymous. Okay, so we seek 1. That puts us at the root node. We test. Now we're testing the pointer left. It's null. Great. This is the offset of this node. It is 1 into the file. Yes. We seek there. We copy f, which is the current node that we are inserting. Yes. We seek 1. We seek t. We should be over the pointer. Yes, we are. We copy x to f. We jump to each entry. Right? So we inserted this into there. That's good. I have a feeling if we do a right side insert, we're going to be messed up. So let's try it. So somewhere We're here for the right side. We seek 3. Okay, that's true. It should be over the last number, which it is. We copy that into t. It is null. So we seek -2. That's our offset. We go there. We get the current node. We go back. That should be a seek 4, maybe? No, that takes care of it. There we go. Okay. What do we end up with? Well, we stomped ourselves at some point. Oh, let's stop at traverse, because that's correct. Traverse, we didn't update all the offsets yet. Okay, so we have all these records. These records are 5 items long. Dude, by the time we get here, we're already 500 cycles in, which means we're already slower than Tyler's solution. But we're just going to do it. We're plowing ahead. Okay. Boom, boom. Okay, wait. What is this seek for? What the hell? Okay. So I think we want to copy 1t here because, again, that's the root node. And then we copy that into x. We seek, we want to get the left node. So we seek by t. And then we need to seek another 2. And we need to put our previous thing in. 1 to t. Copy t to x, seek 2. No, seek t. Why are we copying t to x and then x to f? We seek 2. If f is the parent node, this is making me nervous. We got one instruction left again. So we seek back, we seek t, which puts us at the root node for the first recursion. We seek ahead 2, which puts us at the left link. We copy parent node. We don't want to do that yet. So we copy F to T first. We get the left link, and then we put the parent node in. Note, X is parent node, T is current node. I'm actually making comments. Okay, so we seek T, we seek 2, we copy F to T, we copy X to F, because that is our special slot that we're overloading. It used to mean something else, and now we're making it mean this. So if it's null, we go to output. Otherwise, we seek -2. We copy 0 over that link. And now T is the current node. Fudge. These are in the wrong order. We copy F to T. That's the link in the left node. We put the parent node in F. But now we need to put T into X, and the problem is we already toasted that. Okay, so we go seek 1, copy X to F, seek -2. Of course we can collapse these, but I'm going to sort of leave that self-documenting for now. Copy T to X, copy F to T. Okay, seek -1. Because we just wrote the link, or we read the link. Okay. If we go to output, we just finished with the left link. So the left link is this one. So we go copy seek -4. We copy these two values. And then this one, we seek ahead 1, or no, 2, because we want to recurse down the right node. So we've read these, our file pointer is here. We seek ahead 2, that's the last entry, that's the right node. I want to put comments in here, because I got so confused that I might as well stop trying to be manly and just comment it up. It doesn't cost anything. So we read the right link, we erase it. If it's true, we go to recurse. Otherwise, after having read the right link, we seek to -1, -2, -3. And jump recurse. Otherwise, we're done. I don't know, EXAPUNKS. Well, we're not getting the same one entry over and over. We're getting the same 2 entries over and over with an extra junk character, which I don't know if that comes from know if that happens when... Let me just see what the receiver okay. When we send data for the first time to our buddy, that's in output. So we might be off by 1 here. Yes, we are off by 1. Probably seek minus 3. Okay. Now we're infinite looping probably. Okay, in output, we seek minus 3. Right, because we just read the left link. So we were over the 6, so we go 1, 2, 3. That's correct. We copy that, we copy that. We're seeking 2, we're checking the right link. Putting a 0 there. We actually could do this sooner because, you know, oh, actually, no, we can't. We need to 0 it before we go. Okay, so we seek minus 3. Okay, that's a problem because this value shouldn't be 0. If it's 0, it means we terminate. So some of these values are 0 and some of them are not. Most of them are 0. We're supposed to be writing over that when we recurse in. So let's see. First time we get here, t is 1. So we go there. We put a 0 in the file, which is the parent. That's not the right slot. Oh no, yes it is. Yes it is. Okay, we seek minus 2. We get that. So t should be 1. X should be 6. That's the parent index and our current index. And so we null out the node, and then we jump to node 6, right? So t is current node, t is 6. This is good. This is correct. We seek ahead, and then we go 3. So this is value, left link, our parent index, which we put x. So this should turn to 1. Yes. We seek minus 2. This is the left link. Oh, so we're putting parent index is now 6. Good. We're getting the left link into t. Is it null? No. So we seek minus 1, we null it out, and then we recurse. So now t is current node, t is 21. That sounds wrong to me. Wait, oh yeah, no, because they're multiples of 5 plus 1. So that's 4 5s plus 1. That's great. So we seek t. We go to there. We put our parent node down. We seek minus 2. We get that. It is null, so we go to output. We seek minus 3. We copy to m. We seek 2. We get our right link. We null it out. If it's true, we go to recurse on the right link, but it isn't. Okay, so we seek -3. That should have been seek -2. Wait, I'm confused. Because we put 0, right? -1, -2. Yeah. Okay. That was a lot just to figure that out. What do we got for output? Well, we've now got 3 nodes in order. And then blah, 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 blah. So probably our other case, like our recursing to the right case isn't correct or something. I don't know, dude. Let's check. Let's see if we can check by hand before we start stomping zeros in here. Do all these guys have reasonable parent indices? Parent index is the oh, actually, no, we don't set the parent index until we go down. Oh, crap. So the problem is we're putting this parent index in here on the way down, but we're also rewriting it on the way up. Because everybody just sets the index and jumps back to recurse. So we're overriding the parent index with something bad from the child, for example. Which means when we go up, we probably infinite loop, and that's what we're seeing. So maybe we only write the parent index. We don't have any more instructions. We're very close to this working. Very close. This game is relatively easy, I think. I am trying a difficult solution right now. So we did have a working solution for this level a while ago. Sorry, I haven't been watching the questions in the chat. F reads from a file. T is one of the registers and X is the other register. To start, I would recommend Opus Magnum probably as a Zachtronics game. Infinite Factory also maybe. How many lines for exploration? Not that many. I cut it down earlier today. Well, I mean, there's 2 phases to exploration the way I do it, so it actually is a lot of lines all put together. And I could probably slim it down, but I'm not going to attempt it right now because it's 1:30 in the morning and I'm pretty tired. This used to be longer. I cut it down. I bet we could cut it down more. Yeah, we could totally cut that down more. Is it possible to make functions? So if you make a new probe, you can get them to handle that. You can't really make functions. There's no return statement. How do I, so either I need to set this parent index way back during the first phase, that would be the best time to do it. Or I somehow need an if statement around this. So back before, I was really confused. And I also figured I needed too many statements. Because it's like at this place, so we seek ahead T. We could somehow do the seek T here. Like we need to seek T plus 2, stomp some stuff. Ugh. I feel like I should be able to combine all this better. Anyway, I know what the instructions would be to write in the parent node back here. I think, but it would be 4 more instructions. And actually, might be 6 more instructions. I don't have that much to spare. So I think I'm going to put a note at the top. We're going to go to bed, but I'm going to say note, need to write parent node note in first pass. Oh, we do get some more instructions back because, like I said, putting... Oh, no. Okay. We're screwed. Okay, wait, if we have the parent node stored in this node, then we don't need to do as much stuff. Because like we don't need to maintain X here. We don't need any of these. So we may, if I could do this in 5 instructions, which is unlikely, but maybe, we could do this. The problem is, as soon as I add this, we're going to break everything again, and I'm too tired for that. So we're going to go back to the thing where we have a parent node stored. Like, I don't know, like right after X maybe, even. Somewhere. Maybe after M. So that's going to make this 6 long, which means we change that. But it's going to mean all these individual seeks that we just adjusted need to readjust. So we're going to do that after I've had some sleep. We're getting pretty close on this one, though. Like, this is going to function. And if we need more instructions, then when I'm fresh and awake, we can make this shorter by a bit. It'll be a little slower, but I just want it to work. I want this version to work. You see copy ft, seek -1, add I t5t. Copy ft, seek -1, add I t5t, copy tf. Yeah, you know, you're right. I don't know why. I mean, this could either be add I t5f or this could be add I f5t. That is a good point. Thank you. Sometimes I'm just stupid. So that saves us one instruction. There might be some other dumb stuff like that in here. This thing, I end up wiping out t anyway, so I'm just going to do this. Because it's more obvious. The reason we did the funny way before was because I was doing an add here, which was wrong. Okay, so after some fancy sleep in the morning, we will come back here and we will make it fully work. Gonna add it back right there. Yeah, I'm pretty close. I mean, like I said, I have solutions that work, right? So my best solution, it's been a while since I've gotten, because I've tried a few things after this, but my best solution is this one, which is 1055, which isn't too bad, but Tyler has 499, so like, we gotta do better. Now the thing is, this one is already not 499. Like, just exploring the space here is more. However, we can focus on that again once we're done with this sorting. I think this will be better than 1055. If I were to guess, I'd guess 850. Maybe less, maybe 800. I don't know. We will see when it is done. One more thing, Swizz 103XX can map -3, -1, 1, 3 to another value. Can help in skipping mod-I during exploration. Right, I never thought about what Swizz does. to negative numbers. Oh, I guess it's in the documentation. It negates them, right? Did you check the test case table button at the end of solution verification? No, what does that do? Hold on, let me go back to a working thing. Right, that tells you, so your score is the slowest one, right? So does that tell you, wrong one. Does that tell you which one was your slowest one? That would be cool. Test run data. Ah, I've never done this. So this is like my highest activity, and this is my highest cycles. Yeah, a lot of my runs are less than this. But like I said, I think the new thing will be a lot faster. We'll see. Would I call this the end game content? Yes, I would. Look at how many versions of this puzzle I've tried to do. What I really need to figure out is transmitting the nerve data in parallel. Like, ugh. I could do it in semi-parallel. I mean, I could send 3 guys out the initial room, bring the files back. We'll deal with that later. We'll deal with that later. We've got 6 instructions for you, which we can probably do. 77 different versions. You must have been a beta tester. There's no way to do that since the release of the game. Yeah. Between TIS, Shenzhen, and this, what is the game you spent the most time on? I probably spent more time on Opus Magnum than any other Zachtronics game. Dude, I played Opus Magnum. Seriously. Let's go look at what Steam says my hours are for Opus Magnum, and I'll tell you that I logged all of those hours in 1 week. I played the crap out of that game. Opus Magnum, 107 hours in 1 week, or approximately 1 week. I really played this game very intensely when it came out. All right, let's see if there's anyone that we can host playing a Zachtronics game. Probability is not high, but let's see. Okay, I'm the only person doing EXAPUNKS. Anyone doing Opus Magnum? No. Anyone doing Shen? Oh, no. All right, well, I don't know who to raid now. Let's try. Maybe go back to the Factorio streams. Trying to figure out what looks good. Someone is working on blue science. They're not really saying anything.
Let's go see how much blue we've gotten.
Oh yeah, he is. All right. We'll rate a Factorio. See y'all later. Thanks for stopping by and watching me get oh so close to this solution.